Hello, I'm Kiran Kumar from Nature of Physics. Today topic is intensity of electromagnetic wave. This is part 3 video from the electromagnetic wave. Part 1 video is displacement current and part 2 video is energy density of electromagnetic waves. Clear videos are there. I will provide in the description. And next part 4 video will be pointing back, everything clearly writing, doing video. Student, please like and comment and also subscribe and share to your friends. Students, so the intensity of electromagnetic wave is defined as the energy crossing per unit area per unit time of a source perpendicular to the direction of propagation of the wave. Students, then the light waves are electromagnetic waves. The velocity of light is 3 into 10 to the power of 8 meter per second, and light waves are called transfer waves. Student, okay, and intensity is power divided by area. Intensity I representing power is P and area is A. Student, but power is equal to energy divided by time, so that intensity is equal to energy divided by area into time, and also here volume multiplying and volume dividing. Student, so that intensity is equal to energy divided by volume into volume divided by whole divided by A into time. Student, so that energy per unit volume is energy density, that is capital U by V, and volume is represented by letter V, and denominator is area A and time T. Student, so energy per unit volume is energy density, that is small u writing. Student, and values replacing I is equal to energy density U, and V is volume, and A is the area and T is the time. Student, now intensity I, which is equal to U into volume, is area into length divided by area into time. Student, area is get cancel, so I'm getting here I, which is equal to U L divided by T. Student, so one thing here, this is the velocity of light. Student, and propagating along the cube have the area is A and length is equal to L. Student, and light is propagating across the area A. Student, and the length of the cube is taken L, so that here velocity of light C is equal to L divided by T. So replacing here intensity, which is equal to U into C, I can write this is equation number 1. Student, see, and continuation, next one here, energy value replacing for electric field and also magnetic field and also EM waves. Step by step we will discuss now. Okay, for the electric field, for the electric field I E writing, which is equal to energy density is of epsilon naught E square, and C value as usually writing, this I can write as equation number 2. Students, okay, and next one for the magnetic field writing. Student, for magnetic field, that is IB, which is equal to half into B square divided by mu naught into C. Student, this is I can write as equation number 3. Student, and continuation, next one I'm going to write there energy for the total EM wave. Student, because next one is for EM waves, electromagnetic wave. Student, so that I, which is equal to IE plus IB. Student, okay, and replacing the values, I, which is equal to IE value is half into epsilon naught E square C, and next magnetic field, that is intensity, half into B square divided by mu naught into C. Student, okay, and also next step there is, that is UE is equal to UB. Student, then I can write that is I which is equal to epsilon naught E square into C, otherwise I which is equal to B square divided by mu naught into C, student. I which is equal to half into epsilon naught E square C plus this value also replacing half into epsilon naught E square and C remains same only. See student, this value represent which is equal to I is equal to epsilon naught E square into C, student. Okay, and next for this step also I can write I which is equal to this value replacing half into B square divided by mu naught C plus this value is as usually same half into B square divided by mu naught into C, student, so that this value which is equal to I is equal to B square divided by mu naught into C, student. Please do like and subscribe our channel Nature of Physics.